Okay, in our last lecture, we talked about putting the quadrangle together. What we're going to do now is we're going to densify that quadrangle into townships 6 miles square. Now, once the quadrangle is surveyed, the next step is to create a township. Each township is 480 chains east-west by 480 chains north-south, or a 6 by 6 square, not counting for convergence. So we're going to take that 24-mile square and we're going to break it up into 6-mile chunks. How we're going to divide up this quadrangle is we're going to be running meridional lines called range lines every 6 miles and township lines every 6 miles east-west. So the range lines are going to go north-south and the township lines are going to go east-west. And as we go on with this lecture, you're going to see how all this is going to come together. And there's a very particular way that we need to do it. Now, the range lines are astronomic meridians, true north, south lines. And what they do is they begin at a standard parallel or a baseline, and they run true north to the next standard parallel. And then we will adjust for convergence, and we'll continue doing that. So the range lines run straight north-south from the baseline to the first standard parallel. Now the township lines run east-west. They connect the township corners previously established at intervals of 6 miles. Now remember, when we ran the principal meridian or the guide meridians and the standard parallels, we put monuments at standard measure, they call it, every 40 chains. So what we're doing now is we're running these east-west lines and we're tying into an existing monument. We're running it for 480 chains. Now 480 chains is 6 miles, or it's supposed to be anyhow. Now what you're looking at here is a quadrangle broken up into 6-mile chunks. You'll notice that townships 1, 2, 3, and 4, that is the first range east of the principal meridian. And you'll notice that the meridional line, that is the north-south lines, they start at the baseline at standard corners. That's what SC stands for. And they go to the first standard parallel north, and they have a CC next to them. That's called closing corners. Because these north-south lines, being true north-south lines, they're going to converge or get closer together the farther north they go. So it's not going to be a perfect 6 miles at the top. So we have to adjust for that. So townships 1, 2, 3, and 4 is the first range line. Township 5, 6, 7, and 8 is the second range of townships. 9, 11, 13, and 15 are the next range of townships, and then 10, 12, 14, and 16 are the last range of townships in this particular quadrangle. So what we're looking at here is we have 4 ranges. You'll notice that as I was looking at the third range, it said township 9 and then 11, and 10 was to the east of 9. We'll talk about that as we go on, and you'll see why that happens. Now, if you take a look at townships 1, 5, 9, and 10, that's an east-west line, and that's the first township north of the baseline. 2, 6, 11, and 12 is the second township north of the baseline, so forth and so on. And you'll notice that they're going from principal meridian to guide meridian and from baseline to standard parallel. Now, according to the Manual of Survey Instructions, the regular order of townships are as follows. The south and east boundary of the townships are normally the governed lines of subdivisional surveys. Now, what they're talking about there is once we get finished making the townships, we're going to subdivide the townships into sections 1 mile square. And that south boundary and that east boundary are going to govern those sections. Now, Whenever you can, the township exteriors are surveyed successively through the quadrangle in ranges of townships. They build the first range and then the second range, so forth and so on, beginning with the township in the south. Actually, it's going to begin in the township in the southwest corner of the quadrangle. Now, meridional township boundaries, that is the north-south lines, have precedence in the order of the survey and are run from south to north on a true meridian. I can't emphasize this enough. Remember, they're going on a true meridian or true north. Now, when we're running these meridians, quarter section and section corners are established alternately at permanent corners in standard position. That is, every 40 chains, you go up 40 chains, you have a quarter corner, you go up another 40 chains, you have a section corner, so forth and so on as you go north. Meridional exteriors are terminated when they reach the next standard parallel north. That's where we stop it, because we're going to make some adjustments there. Now, as we're measuring north, as you know, all measurements have errors. So the excess or the deficiency in measurements is placed in the north half mile, and closing corner is established at the point of intersection with the standard parallel. So what we're trying to accomplish is we're going 40 chains and 80 chains all the way north to the next standard parallel, and in the last half mile, if there's any excess or deficiency, that's where we want to place it, because we want to keep as many good squares as possible. So we're going to throw all the error in the last half mile. Now, when you get up to the standard parallel is retraced between the nearest standard corners to the east and west. You come up and you think you're close to the standard parallel, you want to set your quarter corner, and you retrace that standard parallel and find the closest corners to the east and west. And what we're doing that for is to find the exact alignment of the standard parallel. And the distance to the nearest corner is measured and recorded. So we have a record of where that closing corner is going to be with respect to the standard corners. In order to complete the exteriors of the townships, and if defective conditions are not encountered, the latitudinal boundary is run connecting the objective township corners. This is what I'm talking about. We're running the true meridian north-south, and at 6 miles, we're going to run a true parallel of latitude, and we're going to connect into an existing corner that we had previously set. That would make it a senior corner. And because they're a true parallel of latitude, we have to use the transit rule or the secant rule in order to put that on a true parallel of latitude. And that would complete a closed figure of a township, and it would be like a closed traverse. Now, corners are established from east to west along a latitudinal curve, connecting the township corners at intervals of 40 chains and at intersections with meanderable bodies of water, marking the true line. Remember the transit rule and the compass rule, and the secant rule, those types of things. That's what we're going to use. We're going to run these east-west on a true meridian of latitude. By this procedure, the excess or deficiency in measurements is incorporated in the west half mile. Double sets of corners are avoided when unnecessary. Now here's what we're talking about. When we are running the meridional lines, the north-south lines, we put the error running north-south in the last half mile or the north half mile. And in this case, when we're running an east-west line, we're going to start in the east, and we're going to move to the west, and we're going to put all of the excess or deficiency in that last half mile. When lines are run by a random and true method, the bearings of the true line is calculated from the following of the random. Now that sounds pretty strange to you, but it's just another way of doing the same sort of thing. We're not going to go into it a lot right now because we are going to go into that in great detail later on in this class. So I just want to put this in here just to show you that there may be another way that things were done. Now, what I was talking about, this falling is the distance on the normal, which is another way of saying perpendicular, by which is the line falls to the right or the left of the object corner. So if we find an error, there's ways that we can correct this. And I'll show you a graphic of it in the next slide. So this is what we're talking about with the random and true. The two round circles are our corners, and the true line is the green line. And what we could do is we could run a random line, that dashed blue line, to the next meridian or guide meridian or whatever it may be, or wherever we're trying to get to. And once we get to that meridian, we would be south, and we could in some cases be north of where we want the line to be. And so we could measure the distance from where we are to where it's supposed to be. That's called the falling. And then we could use mathematics to correct that line, that blue line, where we have our temporary points, to the true line. And again, we're going to look at this in great detail and later on in this course. Now, where both meridional boundaries are new lines, or where both have been previously established, that is, we've already set up the meridional lines, the latitudinal random line is normally run from east to west. So we're going to start in the east and we're going to close on the west. There are exceptions, and we're going to see that. And again, I can't emphasize this enough. Monuments are placed every 40 chains along these lines, and the error is put in the last half mile in the west. So we're starting in the east, we're putting in monuments for every 40 chains until we get to the west line where we're tying into, and whatever excess or deficiency we have, we're leaving that in the last half mile of our survey. Now, when we're talking about random lines, temporary points on the random lines are replaced by permanent corners on the true lines. So we do the arithmetic, we have our temporary points if we're using this random method, and we're going to correct and we're going to put permanent markers, permanent monuments on the true line. Now, the allowable deviation for a township, that is how far off we can be, is 14 minutes from cardinal. That was the allowable error. There's other errors that we're going to talk about, but with the angular error on the township, the allowable error was 14 minutes. So here's the quadrangle surveyed in. You'll notice that in this graphic, you have 1, 2, 3, 4, 5, 6, 7, 8, so forth and so on. And what this is the lines that are run. Like number 1 there, that's the first line run to subdivide this quadrangle. So we run north for 6 miles, then we run to the west on line number 2. Now you see line number 3 is right there also. So we're going to correct back if we need to on line number 3. Then we go to 4, 5, 6, 7, 8, 9. And line number 10, we're closing on that first standard parallel north. So we have a closing corner there because the lines are converging. Then we come back to the second range and we have 11 through 20 run the same exact way as the first range. But I want to have you take a look at the third range line, line number 21. We come up 21 and we run over to 22. Now remember, that corner has already been surveyed in, so it's a closing corner. We're going to check back, that's why we have line number 23. Then at that point, we're going to run east on line number 24 and check into that first guide meridian because it's already been surveyed. And then we're going to check back on 25. So those the third and fourth range lines of these townships, as we're filling in this quadrangle, we're building them at the same time. And you'll notice the last line we run, line number 36, is to a closing corner. Okay, so that's how we do it. Now what we've done is in this survey, we have captured all the error and the convergence of meridians within a 24-mile square. Now, townships are identified based on the principal meridian in the baseline. So it's going to be a function of where the township is with respect to the principal meridian and that baseline. And you'll see that coming up. Now, east-west rows of townships are numbered consecutively from the principal meridian, and they run north and south. So you would have the first township, the second township, the second township, the third township north of the baseline or south of the baseline. And then you would be able to know where each one of those townships are and how far away it is from the baseline by the number of the township. Now, an individual township is identified by its number north and south of the baseline, as we just talked about, followed by the number east and west of the principal meridian, that is the range. So we can identify any particular township by how many townships north and south or ranges east and west. And you'll see that coming up real soon. An example of calling out a township, you could say, like in this case, it's township 23 north, range 5 east of the Willamette meridian. And they have an abbreviation T23N, comma, R5E, comma, WN. Township 23 north, comma, range 5 east, comma, Willamette meridian. And here's an example. You'll notice that in the middle of this drawing, you have the initial point. So you have the principal meridian running north and south, and you have the baseline running east and west. 24 miles to the north, you have the first standard parallel, and 24 first standard parallel north, and 24 miles to the south, you have the first standard parallel south. 24 miles to the east, you have the first guide meridian east, and 24 miles to the west, you have the first guide meridian west. Well, the first row of townships are called Township 1 North, and what that means is that it's the first township north of the baseline. T2N is an abbreviation for Township 2 North. It's 2 townships, the second township north of the baseline. T3N is the third one, T4N is the fourth one. Now, if you take a look at R1E, that's the first range of townships east of the principal meridian. R2E is the second range. R3E is the fourth range, or third range. R4E is the fourth range, so forth and so on. And the same exact thing is happening to the west. R1W, R2W, R3W, and R4W. By doing this, you have an individual address for each one of the townships because they're all related to whatever meridian, principal meridian, you're working under. Like in Washington, it would be the Willamette meridian. So this is a way that we can identify what township we're working in, which would be a real good idea to know. Now, I want to talk a little bit about acceptable errors, or rectangular limits as they're called. We have a thing in the public land survey system called the 50 link rule for distance. That is, the surveyors back in the day when they were putting this together, they were allowed to have 50 links of error and 80 chains, 50 links in a mile. Remember, a link is 0.66 feet. The 21-minute rule for bearings is 21 minutes for sections. Now, we haven't done a lot of talking about sections, but now that we have the township surveyed, we're going to survey them or densify them into sections. And the allowable limits for a section to be out of true is 21 minutes. But for townships, it's 14 minutes. So it's more restrictive for the township than it is the section. They also have a 5% rule for area. That is, if the area is supposed to be a certain area, and when you do your calculations, you're within 5% of the area that it's supposed to be, you're okay, it's good. If you're more than that, or if you are outside of any one of these limits, that indicates a problem, and you're supposed to go back and check things to see where you made your error. Now, what we've talked about in this lecture is taking the quadrangle and dividing it up into townships. So now we have a survey, closed survey, every 6 miles. In the next lecture, we're going to densify the township into sections. And we're going to make this a little bit different than it has been before. We have a lot of north, south, east, west lines in the townships and in the quadrangles, but you're going to see that in some cases there's going to be a difference when we get into sections. And we're going to cover that in the next lecture.